Okay, so here we have some vocabulary, and we're going to talk about types of equations. So a linear equation comes in the form ax plus b equals c. So any linear equation can be put in that form. A cannot be 0. But B and C could be. Okay, so first we're going to talk about what's called a conditional equation. Let's say we have the equation 2x plus 7 equals 13. Okay, this is what we call a conditional equation. It might be true, might not be true. Depends on what x is, right? We don't know what x is. Now, we can solve this equation by the steps we talked about in the last video. Subtract 7 from both sides, divide by 2, and we get x equals 3. What that means is that if you put 3 into the equation for x, you're going to get a true statement. 3 times 2 is 6, 6 plus 7 is 13. Okay? So if x is 3, then the equation's true. If x is something else, like -1, then it wouldn't be true. That's why it's called conditional equation. It depends on the value of x, okay? All right, when we solve this equation, we get a solution set. So for our little linear equation here, the solution set is 3. Now we use the set brackets like that to indicate the solution set. Now, when you're working in WebAssign, I think they usually put the brackets in for you, so you don't have to put them in. But, if you were writing that and you wanted to write it as a solution set, you would write it like that. There's a solution. The solution is 3 for that particular equation we had. Now, not all equations are conditional equations. Let's say we have the equation 2x plus 3 equals 2x plus 3. Well, you know what? That's always going to be true, isn't it? It doesn't really matter what x is, because you take any number and you put it in for x on both sides here, and you're doing the same operations, right? So it's going to always be equal. This is called an identity equation. Now, sometimes identity equations can maybe not be obvious right away, like that one might be obvious to you. And so you're like, oh, it's an equation, let me solve it. So you would subtract 2x from both sides. And what happens? The x's drop out. They cancel on both sides, and you get this true statement that 3 equals 3. And that means it's true no matter what x is. See, we've lost the x. I'm sorry about that. When you lose the x, one of two things is going to happen. Like if you're solving and you're like, hey, I don't have an x term anymore, one of two things happen. If it's a true statement, it's an identity equation. And if it's not true, we'll talk about that in a minute. Sometimes students get frightened and they're like, hey, I lost my x, let me squeeze one in. Don't do that, okay? It just means it's an identity equation. We didn't do anything wrong. It just means that no matter what x is, whatever real number x is, it's going to make the statement true. So it's not conditional really, because it's true for all real numbers. The solution set is all real numbers. Sometimes they will write that out. Sometimes they will put it in interval notation, which looks like -infinity to infinity. That would be all real numbers. Okay. You also could have a statement like 2x plus 1 equals 2x plus 7. Well, that's not going to be true, right? Like if you have a value for x, and you're going to multiply it by 2, but then on one side you're going to add 1 to it, and the other side you're going to add 7 to it, then it's never going to be true, right? Now, you could say, oh, let me solve this. I don't see what's going on. You could subtract 2x from both sides. That's the procedure to get x on one side. And you get 1 equals 7. Well, 1 doesn't equal 7. This is not true. This is not true. And it's not ever going to be true. It doesn't matter what the value of x is. It's never going to be true. In this case, we say there is no solution. If they want, sometimes they'll write out no solution. If they want it like written a different way, you can use the empty set, which looks like that. Please don't make your zeros look like that. I know in computer classes sometimes they do that, but this is called the empty set. Another way to write the empty set is you put those set brackets, but you don't put anything inside. So that's also the empty set. And sometimes, like I said, they just write out no solution. Okay, so it means there is no solution for this equation. There's no value for x that's going to make it true. All right.